All right, ready to start. Smart contracts with ink, and okay. So yeah, it's such an interesting time, such an interesting moment. Yes, we are almost coming to the end of building smart contracts with ink. Tomorrow is our last session, and today we are going to look at quite a few things, quite some good things, and so much more. So you're most welcome. Oi. Hey. All right, so we somewhere in our session. We are almost starting, and yes, such an interesting time. I think I can take a screenshot. Excuse me. Okay, we're 3 minutes to getting started, and it's such an interesting time, such an interesting place to be. So, a lot is coming. Mm. And we get started. Okay, so it's really time. We can get started. Yesterday we looked at deploying our smart contracts on the smart contracts node locally. The other day we looked at using the contracts UI, and today we are going to go a bit further. So if you come, we want to build an ERC20 token on a substrate-based chain. So if you search for build an ERC20 on substrate, these are some of the suggestions you get, and I think this is a good documentation that we can follow through so that we can build below we should include documentation. So there are already some other additions that you can add on to. Yesterday we saw how we can build an incrementer and also building on a local based chain. So today we are building an ERC20, and okay, let's get started. At this tutorial illustrates how you can build an ERC20 token contract using the Ink language. The ERC20 specification defines a common standard for fungible tokens. Having a standard for the properties that define a token enables developers who follow the specifications to build applications that can interoperate with other products and services. The ERC20 token standard is not the only token standard, but it is one of the most commonly used. So we know that it's one of the most common. Before you begin, generally familiar with smart, verify the following. You are generally familiar with smart contracts. You can go back and revisit our tutorials that we did the last 2 days. So live sessions that we had in the last 2 days and revised. And you can also read through the documentation, both in documentation and substrate documentation. They really elaborate these. That's why I do this with the documentation so that you can have a reference. Let me copy this into the chat also as well. Okay. So you have installed Rust and set up the development environment. Describe and install. If you haven't, you just click on this link and it'll take you there. You have completed prepare your first contract, so you can click and go there. You have completed a developer smart contract and are familiar with how Ink uses Rust attributes macros to build smart contracts. Okay, tutorial objectives, basic. The ERC20 standard defines the interface for most of the smart contracts that run on the Ethereum blockchain. The standard interfaces allow individuals to deploy their own cryptocurrency on top of an existing smart contract platform. If you review the standard, you will notice the following core functions are defined. So you have an ERC20 token standard, you have a contract. So when you have an ERC20 token, there are some standards that are defined, like storage getters. We have public functions right here, and contract events. So event transfer, address index from, then to, and the amount of tokens. So when you transfer, if you want to approve, you approve token owner, address spender, and then the number of tokens, which unit tokens. So when you look at things like transfer, the address to which, and the number of tokens, then it's a public and returns. So these are some of the functions that are part of the ERC20 contract interface. Users' balances are mapped to account addresses, and interfaces allow users to transfer tokens that they own or allow a third party to transfer tokens on their behalf. Most importantly, the smart contract logic must be implemented to ensure that funds are not unintentionally created or destroyed. So we must make sure that the funds are not unintentionally created or destroyed, and that a user's funds are protected from malicious actors. Note that all of the public functions return a bool that only indicates whether the call was successful or not. In Rust, these functions will typically return a result. Okay, you can go through this and know so how you can create the contract supply for the ERC20 token. The initial storage consists of the total supply and the balances. So in video balances, you can delegate. This provides a very good documentation. So I think we can start from here. For the ERC20 token, you can start from here and then create a ERC20 token and then continue. All right. Let me connect this directly. So that we have enough of internet speeds. Okay, so tethering is activated. I think with that we can continue. So to get started, let's create a new project with some template code to build ERC20 token smart contract, open terminal shell. So we are going to start a new Ink smart contract as we have been doing in our tutorials. If you don't already have one open, create a new project named ERC20 by running the following command. So Control Alt T to bring up my terminal, and it does not come, then I can click on it directly. Right, so we have the terminal. And so we can start. Oh, sorry, so we cannot start here. Let me delete that. Home. We can change to documents. And then we cd to ink, and I'll make a directory of day 3. So we are having day 3 of our building Ink smart contracts, and we change to that directory. Yeah, so cargo contract new. You have an ERC20. You can give it whatever name, but let's go with this. So cd ERC20, and open it in VS Code. So we've opened our project in Visual Studio Code, and we have the lib .rs in the minimum. So can go back to our documentation, and then see this, open the lib file in the text editor, replace the default template source code with the following. So we can click on this and see. What I usually do when I'm replacing this source code, I don't just copy. Most of the time, maybe if you've named your smart contract something different, it will become hard for you to know if you have errors. So what I do is I go into my smart contract and then type the smart contract. This also helps me to clearly now start learning that, okay, this is how the pieces are put together. These are the things that I can change, and these are the things that I need to leave. So when you click on that, you will go to this page, and this is the code that we shall copy. So what I'm going to do is I'm going to just keep copying it. I think I have it here extended. So we have the mod ERC20, and then what we are going to do, we shall use the mapping. So if you're going to use the mapping, use So this will help us use the mapping. The mapping is what we shall use to store the addresses and many more things. So this one was explained in the documentation, must be there. Then in contract, module ERC20, then use mapping. So yes, so now here I can create a simple storage. ERC20. Then we're going to change this. So this is how I usually edit the code. The way I'm getting this is I'm going here and I'm reading through this and then I'm editing that code. So you will use that, but I'm going to just keep editing since I have it opened elsewhere. So in our storage, we must have the total token supply. Token supply. In case you have a different name, maybe you've named it ERC20 test token or some other name. Yeah, we just have a few tweaks. I usually rename those ERC20 tokens different names. So we can have total supply. From owner. And when you have three forward slashes, that will be present in the documentation. So from owner, the number of own tokens. Here we're going to have balances. The mapping. Account ID and balance. Account ID. You want to map the owner and the amount that they have. Store it in our simple storage. So now the implementation, we are ERC20. We are going to have a constructor. Which will create a new ERC20. Okay. Image supply. So here we're going to have total supply. Balance. we are returning self. So because we are returning, don't have to have a semicolon at the end. Balances. So these are the balances here. They are assigned to a default mapping. Okay, and calculate the color. So this color is a special name for the address of the owner. So it's a special, and it's a special thing that was put in ink, special attribute. So text m by mv and the color. So now we take the balances and insert. And put the color and then overview of the total supply. And now return. So we have to return something. Self. And the balances. So that's the end of our constructor. Initializes the balances, the owner, and the total supply. So we have a second constructor. This we can remove. And this is why I love to really edit the prevalent smart contract, because then you can easily know that, okay, this is how this smart contract is structured, and so on and so forth. Okay. So now we go to our message, and these are the public smart contracts that will be accessible by the user. We can also delete this. Okay. We shall have a total supply. So the deployer will give the total supply, and ship also the balances, maybe when they supply, when they give out some of the tokens and things like that. Supply, so on self, this one will have a return type balances. Balance, and then we have a return type of self, total supply. Then also we shall have a balance. So this one simple and squarely and supply. So this one returns the account balance of the specified owner, account balance of the specified owner. I think we are going to have balance. So balance of so we are returning a type of balance, a bool, because so self dot balances dot get owner unwrap or default. And yes, so unwrap or default was one of the things that was seen in Rust. You read Rust, things like clone, unwrap, default, match is so. And yeah, so I think we are going to go to the testing. This is just a bare bone minimum smart contract. So the tests. Define some help accounts. Make what is more readable. Default works. And so this accounts take quite some time. So let me just copy them and then by there too. So we can have them. FN this. So these are just accounts to make sure that we are working, that our tests are working. You have an Bob's account which returns an ID. accounts.bob. And then we go to the tests. Type of annotation needed. We shall come back to that. Default accounts. With that error, I will return ink. In the environment variable test. Default account.
Karibu. Viani. Kama mpeka kopi hapo.
Wagule.
Waje?
Wagule.
Wagule? Kari munda. Kari kumeza. Environment, sorry about that. So I have a return of ink. This is quite big, but yes. Environment testing. Paste. Default account. That since it's the return type. Here there is some FN default accounts, return ink. And the test on default accounts, environment. What's the error? The name default accounts is defined multiple times. Must be defined only once in the value namespace. Okay. Must not be here. I think here we should have used super.
And yeah, I think that error is gone. So now we can go to our tests and so FN default works. I think here we are just going to have FN new works. So we can let here C20, or we can call it late contract so that it's not confused. ERC20 is on default. New, give it 777 since these are tests, so give it any other. So we assert equal contracted total supply. We are considering if we have given the supply to be 777 tokens. So an assertion could be equaling again to 777 tokens. Then we can go to another test to test for the balance. So yes. Test for the balance works. And FN, I can call it balance works. So let give it balance as 100 tokens. Have an assert equal to supply to be 100. And then contract. So balance of Alice, the deployer, is also 100. And in this case, balance of Bob is 0. So that's it. So I think this we can go with. And yes, I think our test is passing. And then we open here, terminal new, or we just control and the snake sign. And then we go to test. Okay, we can go back to our documentation and the cargo test. So even this is also how we can run our tests. This here, and then see. So cargo contract build, and then we upload it the same way we're uploading the smart contracts to the contract CUI, at least for the next few minutes, in case the test passes. So the test is okay. So the next thing can be to deploy. But as you look at this documentation, there are many other things that you can add in. You can add in the transferring of tokens, events, and many more things. So yes, you can keep on testing and iterating. You can find this documentation at this link, docs.substrate.io smart contracts, build a token contract. Or you can search for build an ERC20 token contract on Substrate. All right, so we're going to do something about building a front end. So you have your smart contracts, or you want to deploy a Substrate based chain that has its smart contracts inbuilt. For example, a Substrate based chain which has its token already, and things like that. So when you go to the documentation, here there is front end, and when you look at front end, there is overview, and yeah, this is the overview. So now after you wrote, compiled, and deployed your smart contract, it is time to craft a user experience around it. So this experience can take many steps from mobile app, interactive terminals, applications. In this section, we are focusing on the most through right now, which is web apps. So although we love Rust, the native language of the web script, thereby naturally the best tools for creating web experiences are available for JavaScript. Hence, the tools for smart contract interaction with JavaScript are the most advanced as well. To be precise, all JavaScript tools mentioned here actually leverage TypeScript to offer a JavaScript and a type-safe TypeScript experience. So JavaScript has TypeScript tools. There are several levels of abstraction. Can start with the journey of creating a web front end for your contracts. Each level has different advantages and disadvantages. The following is a list of tools. So you have the RPC interface, not recommended. When you can click on these links and then go, we have the Polkadot/API. We have also Polkadot/API contract. You can look through. And see how you can build your front end, getting started, installation, basics, code, import. So you have to import the code promise from Polkadot. Then you instantiate the code promise with the API metadata, and so in case you have your React app or yes, a TypeScript app, and so this is a good thing that you can come back to and always interface with it. So there is those who are using React, use Inkathon and React and Next.js. So for me, what I'm going to do is I'm going to use Inkathon, so React and Next.js, and we're just going to make sure that we create our own front end and our own DApp is using Inkathon just for beginner. And yeah, so Inkathon is a GitHub repo, and I think it's a good repo. It's a full stack DApp boilerplate for Ink smart contracts with an integrated front end. It can quickly start developing your hackathon ideas to scaffold a production-ready Web3 application. The project is part of a social lab initiative to improve the developer experience in the Ink ecosystem, and a proud member of LIVE3 EFP. So LIVE3, yes, if you want to get funding as you're building your Ink smart contracts. So these links are good to always go through. This is a LIVE3 EFP. So I think this EFP is like funding ecosystem. It's a funding place where they have over 45 million USD in pool. So yes, you can build your project, apply for these, and yes, keep building. Okay, so but let me stop that there, and then other projects include create Ink app coming soon, Inkathon boilerplate, use Ink, Z Ink. You can join the Telegram group as well if you're really interested and you're going the Ink direction. And if you want to contribute, there are contributor guidelines. So about the boilerplate comes with a small sample Ink creator contract, which stores a message, the greeting, and allows anyone to update it. So the front end contains simple UI components to connect your wallet and interact with the contract, i.e. read and write the message. So try it live. So getting started, we are going to run the front end. The front end works out of the box without a local node running, as the sample contract is pre-deployed on certain live testnets. That's LF0 and Shibuya for those in Astar testnet. Shibuya and Shibeni. Okay, necessary deployment metadata and address are provided under contract deployment. So prerequisite setup, node version recommended using NVM. So you must have node npm npmi, so you must have also pnpm and clone the repository. So therefore this we can clone the repository. So git clone and code copy. So after cloning the repository, so special instructions for Windows users. Okay, build and deploy contract on local node. So the contract package your session file, return scripts for building, testing, and deploying your contracts. To run these scripts, you need a set of contracts as the active working directory. So prerequisite, install Rust, a cargo contract, and then a substrate contracts node. So build and connect the front end to the local node. At least we can ls Inkathon code. Let's first close this. GitHub contracts, other front end, and build up, and then we run this. And for now, deployed another contract. That guide is a good guide, but so Next.js or React, and we have the pages component. So we want to change the UI, button, cards, label, form, play around with these, and then you change probably your form. Wait for these to build up. So deploy contracts manually using the contract UI. Connect the front end to the local in your VS Studio. So these are still showing this because of the analyzers, but we can just leave those alone. So you can come to the tree. Here, and then we install it. So custom scripts, changes scripts, live examples, A0 ID. So below you find live examples that use this boilerplate or have a similar setup inspired by it. Okay. Compiled. Okay, so so yes, this is the boilerplate, and you can see that we are connecting to LIVE3 testnet. This is still. So this is account. You can get testnet. So a greater smart contract is already deployed. So wait for this to load. So here my smart contract is already connected because I've been testing this with sub wallet. So probably I can first disconnect. So as soon as I disconnect and say connect wallet, so I connect sub wallet. So my sub wallet is already, but I can disconnect and connect with probably Polkadot.js. So you see that auth is already here, and you allow this application access. So reject. So it comes out of the box with the connect wallet button. You can place it anywhere you want and then connect. So mine shows here. If you want to sort of bring your testnet, and so my testnet 0 is here, and I have some tokens for test tokens. LIVE3 test token. You come here, and then manage tokens. This is where you research for LIVE3 testnet. So LIVE3 and testnet of RF0. If you want to test on color, you want to test on
on any other smart contracts, Fala smart contracts, if you want to test on all the chains that allow smart contracts, on Shibuya, yes, on Asta, you can just come there and then search for your token, add it, and then it will be now visible here among this list. On test on Rococo, Shibuya. Okay. You can update Rita. And track code says hello, submit. So when I submit, I have to sign with my Substrate wallet. You can submit with any other wallet. So, and you see the transaction was successful. It was on chain. I can view it on, and it is here. The central code says hello, so it is here fetched here. In case you want to change deployment to a local deployment, you come to a front end, and env.local, and change here to this next default development. You can also change to other chains like Aleph0 testnet, Rococo, Shibuya, and you can also change this to where you've deployed, and you can deploy probably to Vercel. So we've covered that, and this marks the end of our session today. Yes, tomorrow we shall be winding up. Probably maybe we could have something to do with the Rococo testnet for parachains. And yes, this is a very good thing to try with, to think around with. You can also get, I think, you can. Okay.